Hello everyone, let's start today's topic, which is principle of transmissibility. We must understand this particular topic so that we can have a sound knowledge of all the topics which we have covered till now and the topics which we are going to cover in our upcoming chapters. So let us discuss the first topic of today's session, which is principle of transmissibility. Right? For understanding this, let us start with all the consideration or assumptions which we need to do. So first of all, let us consider that we are having two rigid bodies, block A and block B. As you can see here in the picture, block A and block B. Right, so here are block A and block B. These are two figures or two bodies which we will be considering in understanding of principle of transmissibility. Now, let us assume that two rigid bodies are joined with each other with the help of rigid rod. Right, so as you can see here, there is a rod which has attached both the bodies very rigidly. Right. So now, what is our consideration over here? We are having two rigid bodies, body number A and body B. And both the bodies A and B are connected with each other using a rigid rod, right? And that rod is also made up of a rigid material. If we recall, we remember that we have already covered rigid bodies. So any body which does not deform or does not change its shape under external forces, then it is termed as rigid body. Right? So any body which neither deform nor break down while applying external forces, it is termed as rigid body. So now here we consider this as our rigid body. So the given condition is both the bodies A and B and the rod, all the three components which we have used to understand this principle are made up of rigid body. Now, let us apply force F over the object B, and hence the system, that is both the rigid body A and B and also the rigid rod, will move toward the right direction. If you can see here, right, so if I'll apply force in the direction of this body B, so both the body A and B along with the rod will move in this particular direction of the applied force, right? And in other words, if we want to say, we can say that we are applying force here, the pulling force. It is not a pushing force but a pulling force, and the system is moving towards the right direction under the action of this particular pulling force. Now, let us consider that applying the action of pushing force. So, how we can apply the action of pushing force? Let us apply the force F to our block, which is block A. If we apply force F to this particular block A, it will be a pushing force, and again the system is moving towards the right direction under the action of this particular pushing force. The most important observation from this particular learning is that pushing force or pulling force will produce the same effect, right? Both of them will produce the same effect. So this is what we need to understand from this particular point, that either it is a pushing force or a pulling force, it will have the same effect. If you can see, in both the case, it is moving in the right direction under the action of force, right? So here you can see in the both the things or both the ways, they are moving under the right direction under the action of force, whether you apply force, pulling force on the block B or you apply pushing force on the block A. Now, That was about principle of transmissibility, which says that pushing and pulling force have the same impact. Now, let us consider the next principle, which is principle of superposition of forces. So, what do we understand by this? So, this particular principle of superposition of forces states that the combined effect of force system acting on a particle or a rigid body is basically sum of effect of individual forces. That means whatever amount of force is experienced by a given body will be summation of individual forces acting on that particular body. So we must understand and we must remember this particular principle. So now here let us consider two forces. As you can see here, there is a force P and force Q which is acting on a boat, right, at point A. So this is our boat, and at point A we are applying a force, right, and this force is P and Q. So if we consider that R is the resultant force, then according to Newton's second law of motion, the boat will move in the direction of resultant force, F equals to mass into acceleration. So with the acceleration which is proportional to the applied force in the direction of R, the motion of the boat will be done. So this particular principle states that whatever force is experienced by the given body, it is just the combined effect of total forces which is acting on that particular particle or a rigid body, and it will be the sum of all the individual forces. And the same motion can be obtained when P and Q are simultaneously applied, right? So this is what we mean or we understand by principle of superposition of forces. The next one is law of gravitation. So what do we mean by law of gravitation? Any particle or matter in the universe attracts another with the force varying directly as product of masses and inversely as square of distance between them, right? We know that, but the bodies we are dealing with tend to be larger. So to simplify the situation, we assume that body act as if its entire mass is concentrated at a given specific point, and that point is known as center of mass, right? We consider that mass of entire body is concentrated at one single point, and that is nothing but center of mass. Now, linear momentum and collision can be explained, which is using this particular property, right? So for two bodies which is having mass m and capital M, so here we have considered two bodies, one with mass small m and another with mass capital M, right? So there is a distance r between both of them, and this r, that is the distance between center of both the masses. Small body and big body both are separated from each other using the distance r, and this r is a distance between center of their body mass or center mass, right? So that is r. So when you will apply force m in this direction and force m from the direction opposite to it, for two bodies having mass m and capital M with a distance r between them, their center of masses, the equation of Newton's universal law of gravity can be given by force equal to gravity capital G into masses of both the body in product form, that is m into capital M, divided by distance square. So here F is the magnitude of gravitational force, whereas G is the proportionality factor called gravitational constant, right? So this is our law of gravitation. We must understand this formula, what does it mean, what it try to say, and we must learn or remember this particular formula. So force or magnitude of gravitational force is equivalent to gravitational constant multiplied with product of both the bodies or center of mass of both the bodies divided by distance between their centers square, right? So that is law of gravity. Now come to parallelogram law of forces. It states that if two concurrent forces acting simultaneously on a body is represented in magnitude and direction by two sides of a parallelogram, then the resultant may be represented in magnitude and in direction by diagonal of the parallelogram. So here if you can see, Q and P are two forces which are acting as a side of parallelogram. So the resultant force can be represented using diagonal of parallelogram. So this particular law is law of parallelogram for the forces. I hope all the topics which we have covered today is quite clear.